Imagine you are trying to film a time lapse of a mountain glacier melting, right? But over the course of an entire century.
Okay, so you would need the camera absolutely bolted down, like completely untouched, right to the bedrock.
Exactly. But instead, every 5 minutes, someone walking past just grabs the camera to, take a selfie.
Oh, or they unplug it because they need the outlet to charge their phone.
Right. You want to understand these massive, slow-moving environmental systems, but the people actually holding the camera have these incredibly short-term, immediate priorities.
Which completely destroys the continuity. I mean, you can't measure slow geological time if the person holding the equipment keeps moving it or, changing the subject entirely.
And that brings us perfectly to the muddy, totally chaotic waters of early American environmental science. Because to truly measure a continent, you have to bolt the camera down.
Yeah, you really do.
So today we are doing a deep dive into how a quiet, seemingly, bureaucratic law from 1928, the McSweeney-McNary Act, became the bedrock that finally bolted down American forest science for good.
It is such an incredible story. And we pulled together a really fascinating stack of sources for you, the listener, to unpack all of this.
Yeah, we have the actual public domain text of the 1928 statute itself, which is officially known as 45 Stat 699.
We're also looking at a 1947 United Nations FAO account, and that was written by a senior Forest Service official named Edward Kotok.
Plus, this incredibly vivid historical essay by Ivan Doig, and a highly specialized dossier that just tracks the history of forest experiment stations.
So our mission for this deep dive is to walk you through why a scattered, honestly frustrated group of field scientists desperately needed a federal statute just to survive.
Just to keep the lights on, basically.
Exactly. We're going to explore how this law built this unbreachable structural firewall to protect long-term data from short-term politics.
And finally, we'll follow a researcher named Thornton Munger and his crew straight into the rainy, super dense Douglas-fir woods in 1929.
To do something that sounds, frankly, physically impossible. Systematically counting a continent of trees.
Which is wild. But okay, to appreciate the sheer relief of that 1928 law, we have to look at what those scientists were dealing with beforehand.
Oh, absolutely. The pre-1928 landscape was rough.
Because if you look at the 1920s, the U.S. Forest Service wasn't actually starting from scratch. Congress had first funded federal forestry investigations way back in 1876.
Yeah, which is well before the national forest even existed as we know them today.
Right. And they had managed to set up these scattered regional labs over the years.
Like you had the Fort Valley Station down in Arizona, which started up in 1908, I think, mostly to figure out why ponderosa pines just weren't regenerating.
And there was the Forest Products Laboratory in Wisconsin opening in 1910.
Exactly. And by 1915, there was even a dedicated research branch within the Forest Service, so science technically had a seat at the table.
But according to that FAO account by Edward Kotok, that seat at the table was totally an illusion. The sources describe the research branch as living on borrowed time and borrowed money.
Because the research was trapped entirely inside the land administration machinery.
What does that mean exactly?
Well, the scientists basically had to compete for the exact same regional budget dollars as the local forest rangers.
Okay, wait, think about it like this for the listener. Imagine you manage a fast food franchise. You're the shift manager.
Okay, I'm with you.
Your primary job is dealing with the lunch rush, right? Making sure the registers work, keeping the floors clean. Now imagine corporate tells you that you also have to fund a 50-year nutritional study out of your daily register till.
Oh, I see where this is going.
Of course the science is going to get cut. I mean, if the roof leaks or the fryer breaks, you are going to pull the budget from that slow, invisible science project to fix the immediate emergency.
That is the exact dynamic that played out in the national forests.
It makes total sense when you put it like that.
Right. Imagine you're a scientist trying to run a multi-decade study on tree growth rings or, soil erosion. Your funding is controlled by the local regional forester.
And their job isn't science.
No, their primary job is managing active timber sales, issuing cattle grazing permits, fixing washed-out roads.
So if a massive wildfire breaks out in year 3 of your 50-year study,
the regional forester is going to take your research budget to buy shovels and hire fire crews, period.
Which means forest science was essentially a joke. Like, you cannot predict a 100-year growth cycle if your boss cancels the project in year 3 to buy a new pickup truck.
Exactly. Because true ecological science requires strict continuity. To really know how a forest grows or how a disease spreads, or how a watershed reacts to drought.
You have to bolt the camera down.
Yes. You have to measure the exact same plot of land using the exact same metrics for decades. Discretionary funding just ruins that.
Because it's money handed out at the whim of local land managers.
Right, which makes scientific continuity impossible. The people managing the land for commercial or public use simply have entirely different imperatives than the people trying to measure its underlying biology.
So these foresters, they eventually realized that asking nicely for budget protection just wasn't working.
No, not at all. Because scientific continuity could not survive under the constant pressure of day-to-day land administration. They needed a structural fix.
They need a law.
And that structural fix finally arrived in Congress on May 22, 1928, in the form of the McSweeney-McNary Forest Research Act.
Sponsored by Representative John R. McSweeney of Ohio and Senator Charles L. McNary of Oregon.
Yeah, and McNary's actually a really notable figure in conservation history. He was a powerful legislator who championed several landmark forestry laws.
But the sources actually point to a guy named Earl H. Clapp as the real intellectual force behind this specific act.
Oh, definitely. Clapp was a Forest Service research leader, and he worked super closely with the Society of American Foresters
to basically prepare this exhaustive, totally undeniable analysis for Congress.
Proving that the nation was basically flying blind regarding its natural resources. Clapp's core argument was that you cannot run a national timber economy without an independent scientific ledger.
And when Congress finally passed the act, it did 4 monumental things, right?
Yes, 4 massive changes. First, it legitimized the experiment stations. It took that scattershot collection of ad hoc field labs and formally authorized a permanent, recognized system of regional experiment stations across the whole country.
Okay, that's huge. What was the second?
Second, it officially separated research from administration. Third, it authorized 10-year appropriations. And fourth, it chartered a nationwide forest survey.
But wait, looking at this list, I mean, the biggest victory here wasn't some flashy scientific breakthrough in a laboratory. It was essentially an organizational chart update.
I know it sounds boring, but that organizational update changed the entire trajectory of American ecology.
Really? Just by moving boxes around on a chart?
Yeah, because by legally separating research from administration, Congress created a statutory firewall against political and managerial interference.
Ah, so the shift manager can't raid the till anymore.
Exactly. They cemented the principle that science answers to science, not to the regional foresters who are busy running timber sales.
It bolts the camera to the bedrock.
Yes. And by authorizing those appropriations over a 10-year horizon, the law gave the science financial predictability.
So they weren't just living year to year.
Right. The scientists weren't living at the mercy of a single year's budget whims or a sudden local emergency. They finally had the legal and financial scaffolding to design studies that would actually outlive them.
Okay, so they get the firewall built and the funding is finally secured. But a law on paper doesn't automatically equal a functioning scientific institution.
No, it definitely doesn't.
Because having independence is great, but how did they actually prevent this new money from just turning into a chaotic free-for-all of, like, random pet projects?
Right, they had to organize a continent's worth of ecology into something coherent. And the genius of the Act's implementation was how it structured federal forest research.
Into those 6 enduring lines of work.
Exactly.
I was looking at the breakdown of these new departments, and it's wild how specific they got. They didn't just tell the scientists to, go study trees.
No, they divided the entire ecosystem into distinct ledgers.
Yeah, the sources list them as, let's see, forest management, which is silviculture and how to actually grow trees. Then forest products utilization, figuring out what to do with the wood.
And forest protection, which was tackling fire, insects, and disease.
Right. Then there was forest influences, range research for grazing lands, and forest economics, dealing with taxes and timber markets.
The naming of these categories right there in the statute is what gave them permanent standing.
Because it was written into law.
Exactly.
Yeah.
By officially recognizing a category like forest economics or forest protection, Congress ensured that no vital area of natural resource science could be easily ignored or defunded just because it wasn't currently trending.
Every single part of the forest ecosystem got its own dedicated protected lane. But I really want to highlight the one called forest influences because that sounds incredibly vague for a scientific department.
It does sound a bit mysterious, yeah. But at the time, forest influences was essentially watershed and climate science.
Okay, so studying how the forest affects the environment around it.
Right. It meant studying the effect of the forest canopy on water runoff, soil erosion, and local microclimates. It was a recognition that a forest does way more than just produce wood.
It influences the fundamental systems of the earth.
Exactly.
And having a dedicated department for influences paid off in ways they couldn't possibly have imagined in 1928, because decades later, it was this specific protected line of work that delivered massive world-changing environmental discoveries.
Oh, absolutely, like the existence of acid rain.
Wait, really? Acid rain came out of this?
Yeah. Because these scientists had been methodically studying the relationship between the atmosphere, the tree canopy, and the soil for decades, they had the continuous, long-term baseline data required to actually prove it.
To prove that the rain itself was changing.
Exactly, to prove that precipitation was fundamentally changing on a chemical level. That breakthrough simply does not happen without a permanent, legally protected Department of Forest Influences collecting data year after year.
Wow. Okay, so they have the money, they have the firewall separating them from the timber salespeople, and they have the 6 departments organized.
Yep, the whole structure is there.
But money in a bank account and an organizational chart do not measure a tree. How do they actually apply this out in the wild?
Because the fourth major pillar of the 1928 Act was an order from Congress to conduct a nationwide inventory of the country's forest capital.
The Nationwide Forest Survey.
Exactly. Congress realized the country was burning and logging its forests at just an alarming rate, but nobody actually knew how much was left.
It was an economy running without a balance sheet.
Which is terrifying.
Huh.
So the survey was designed to answer 4 fundamental questions. What was the inventory of existing timber by volume and type?
Okay, question 1.
How fast was it depleting through logging, fire, insects, and disease? How fast was the forest naturally growing back? And what would the nation actually require for forest products in the future?
But to answer those questions, someone had to actually go out and count the trees. And we are talking about roughly 648 million acres of forest land in the United States.
It's unfathomable amount of land.
I read that they used something akin to Scandinavian strip surveys, but what does that actually mean in practice? Because you aren't just walking into the woods with a clipboard and pointing at trees.
No, not at all. Surveying every single acre, property by property, was mathematically and physically impossible. So they had to pioneer brilliant statistical sampling methods.
Okay, so how does a strip survey work?
Well, the Scandinavian strip survey method means that instead of just wandering around, you walk a precise, mathematically predetermined straight line through the
Or a
wilderness.
completely straight line?
Yes, you take a compass bearing, and you do not deviate.
So you're just bushwhacking in a perfectly straight line no matter what is in front of you.
You go over ravines, through swamps, right over cliffs. You measure a strip of land, traditionally 1 Gunter's chain wide, which is exactly 66 feet. And as your crew moves along that strict compass bearing, you tally the diameter, height, and species of every single tree within that 66-foot corridor.
Wow. For how long?
You do this for miles. Then you move over a predetermined distance, say 3 miles, and you walk a parallel strip all the way back.
And because you know exactly how much area is in that specific 66-foot strip, you can take that incredibly accurate sample and extrapolate it across the thousands of acres between your strips.
Exactly. It allows you to calculate the volume of a massive forest without literally counting every single tree.
But the physical execution of this must have been just monumental. The sources highlight a specific researcher named Thornton Munger.
Yes, Munger is legendary for this. In 1929, operating out of the newly fortified Pacific Northwest Forest and Range Experiment Station, he led crews to officially launch this nationwide survey.
And they started in the Douglas-fir region of Oregon and Washington. Ivan Doig's historical essay paints such a vivid picture of this landscape.
So it really does.
I just picture Munger's crews in 1929 in the absolute pouring rain of the Pacific Northwest, pushing through these endless, towering thickets of Devil's Club and massive Douglas firs.
Dragging these heavy 66-foot metal measurement chains through the mud.
Trying to keep their soggy notebooks dry, yelling out tree diameters over the sound of the wind.
And trying to make sure they don't count the same giant tree twice while navigating, steep, treacherous ravines.
It sounds like an absolute nightmare.
It was grueling physical labor, but it laid the groundwork for all modern forest inventories. What Munger and his crews were doing wasn't just counting wood to see how many 2x4s they could mill.
Right.
They were conducting the very first comprehensive accounting of America's natural capital.
They were proving that massive-scale, nationwide ecological sampling was mathematically and physically possible.
And they just kept walking those lines.
Yeah.
By the time the United States entered World War II in 1941, which obviously forced a pause in the effort, they had successfully inventoried about half of the nation's total forest area.
That is just incredible. And I know later on they would start supplementing this brutal ground truthing with early aerial photography to make the extrapolation even more accurate.
Yeah, which is a staggering achievement for that era.
Yeah.
And honestly, the reason we are exploring this specific history today is that Munger's boots-on-the-ground survey in 1929 wasn't just an isolated historical event.
Right. It's not just a fun fact from the past.
No, it was the birth of a continuous data set that you, as a listener and a citizen today, still actively rely on.
Exactly. Why should you care about the McSweeney-McNary Act of 1928? Because that 1929 survey launch is the direct ancestor of today's Forest Inventory and Analysis Program, the FIA.
Which is essentially the continuous National Forest Census.
And that continuous census underpins absolutely everything we do today regarding the environment. It provides the baseline data for the entire country.
Right. Every time you read an article debating the effectiveness of carbon capture in our forests, you are reading data derived from this continuous survey.
When you watch a news report analyzing the escalating risks of mega wildfires, or you look at economic projections for building materials,
You are relying on a data set that only exists because this structural firewall was built.
if the fast food shift managers were still in charge of the science budget, none of that modern data would exist.
None of it. Patient, place-based measurement is a hard-won truth. And the historical record makes a really compelling argument that this kind of truth is incredibly easy to destroy and painfully slow to rebuild.
Without statutory protection, modern data collection remains incredibly vulnerable to whoever happens to be running the land or running the budget at any given moment.
And it all comes back to the camera on the bedrock.
Yes, if you don't build a legal fortress around it, someone is going to bump it. The 1928 law proves that to know the environment continuously, to truly understand the scale of what we have and what we are actively losing science, must be protected by law from political and managerial interference.
The framers of the McSweeney-McNary Act recognized a fundamental structural conflict of interest. They realized you simply cannot trust the people whose primary job is selling the timber to objectively and independently measure the health of the entire forest over a century.
You have to separate the scientists from the salespeople.
You really do.
And it forces you to look at how we gather the facts that define our reality today. We've explored how a scattered, frustrated group of field plots living on borrowed time became a unified, protected national science, all thanks to a group of forward-thinking researchers and a 1928 statute.
We followed Thornton Munger into the muddy woods to count a continent, and we saw how that grueling work built the foundation for the environmental data we use constantly today.
Thank you so much for coming along on this deep dive into the roots of American forest science.
And as we wrap up, I want you to consider this. The 1928 Act proved that environmental science cannot survive on discretionary funds and administrative goodwill. It requires absolute statutory independence. So if you look at the modern world, how many vital environmental data sets out there right now, systems tracking our oceans, our atmosphere, our soil, are sitting completely unprotected?
How many of our modern scientific efforts are operating on borrowed time and borrowed money, just waiting for their own McSweeney-McNary Act to ensure they actually survive the century?